Assalamu alaikum everyone. In this presentation, me and my colleagues are going to discuss the analysis of Sheikh Salman Highway. Some information and characteristics about Sheikh Salman Highway. The whole highway is 7 kilometers long approximately, and it is 6-lane highway with a speed limit of 80 kilometers per hour. We choose a segment from the signal near Al-Haddad Motors to the signal near the Directorate of Traffic. And it is shown here with a black line in the figure. And this segment is approximately 3.5 kilometers long. We found the lane width to be 3.6 meters and the shoulder width around 3.2 meters and the median with 5.2 meters. All these dimensions we get it from the Google Earth. Time we visit the site, we collect volume and speed data for 15 minutes just to make sure that we can stay at a safe and clear position, to see the road clearly and to be able to collect the data. So we record the time by taking each vehicle to cover a distance of 100 meters. Then we found the speed by using the velocity or speed equals to distance over time. And one of us was counting the volume and it was 619 vehicles for one direction. Speed studies. This study can be counted for a point or a short segment, and by short segments we mean less than 1,000 feet. We are doing this study to find the free flow speed of the drivers in the free flow conditions, depending on the road characteristics, not the traffic stream. So we choose a segment of 100 meter long to do this study. Shown in the table here, we collect 62 spot speed samples from the site when the traffic is low. We did the same procedure in the previous speed data collection as we was recording the time for each vehicle that it takes to cover 100 meters. Then we found the velocities and also we found the free flow speed, which is the average of these 62 speeds, and it is equal to 87.38 kilometers per hour. Data is considered as a continuous frequency distribution. So we divided the speed into groups as shown in the table here. We choose an interval of 5 kilometers per hour for each group. Then we record how many vehicles were observed for each group. And we found the percentage of the observed frequency by dividing the observed frequency over the total number of samples, and it is 62. Then we found the cumulative percentage frequency. By using the data in a previous table, we plot frequency distribution curve by plotting middle speed on the x-axis and the percentage frequency on the y-axis. As we see here, the curve has a bell shape, and this curve will be used to find some parameters. We will discuss it in the next slides. Also, we plot cumulative frequency distribution curve by plotting the upper limit speed on the x-axis and the cumulative percentage frequency on the y-axis.
From frequency distribution table, we found central tendency parameters, and central tendency is defined as an approximate middle or center of data. We calculate the mean by using this formula, and the values here are taken from frequency distribution table above, and we found it to be 87.74 km per hour. Also, we found the median using cumulative frequency distribution curve by plotting a line from the y-axis at 50% till it intersects with the curve. Then we found the corresponding value at the x-axis, so we found the median to be 87 km per hour. Another parameter of central tendency is base. It is found using frequency distribution curve, and it's defined as 10 mile per hour increment in speeds that represents the highest portion of observed speed. So we found the base range to be from 79.4 to 95.5 km per hour. Then we find the mode. It is defined as the single value of speed that most likely to occur, and it is the peak of probability distribution curve as shown. We found the mode to be 87.8 km per hour. After that, we found dispersion parameters, and they are standard deviation and percentage of vehicle within the base range. So here's the formula for standard deviation, and the values are taken from frequency distribution table. As shown, we found it to be 12.93 km per hour. For percentage of vehicle within the base range, we will use cumulative frequency distribution curves as shown. In the previous slide, we calculate the base range, so we took the corresponding y-coordinates of these values, and we found the percentage is 74% and 26.5%. So this percentage will be 74 minus 26.5%, and we found that to be 48.5 of the drivers within the base range. After that, we calculate the confidence intervals. At the first, we calculated E, which is the standard error, and as shown, it's the standard deviation divided by the square root of number of samples, and it's found to be 1.642. And also, the mean value is calculated before as 87.74 km per hour. Then we calculated the 95% confidence interval, and the formula is shown that's the mean plus or minus 1.97 by E. So the 95% confidence interval ranges 84.52 to 90.96 km per hour. We did the same procedure to find 99.7 percentage confidence interval, and we found it to be 82.81 to 92.76 km per hour. The last thing we did regarding the spot speed data is chi-square test. It is the test to check if the data follows normal distribution or not. The table of chi-square test is shown here. After combining the groups which has theoretical frequency less than 5, we have 7 groups. So we found the degree of freedom as the number of groups after combining. With 7 minus 3, we have got 4. Chi-square value is 5.429. So using chi-square table, we found that this value is between the probability of 0.252 and 0.5. So we did the calculation shown here to find the probability. After solving the equations, we found the probability is 26.74%. So our data follows normal distribution because the probability is greater than 5%.
The second time we visited the site was to collect volume data at the peak hour for each direction. So we collected volume data for 2 hours at 12 minutes counting period as shown, with 3 minutes break between each period. We counted the number of passenger cars as well as the number of heavy vehicles. The column of passenger car counts is showing the total number of cars for each period for the 3 lanes, and the column for heavy vehicle counts is showing the total number of heavy vehicles for all the 3 lanes, and the third column, the total count, is showing the summation of heavy vehicle counts and passenger car counts. And the same procedure is done for the other direction. The table shown here is showing the converted counts to 15 minutes counting period, and that's done by multiplying the value from the previous table by 15 and then divided by 12. The same procedure is repeated for all the values converted to 15 minutes counting period. As we have seen in the previous table that we have the data for 2 hours. So we need to find the exact peak hour. And this is done by finding the volumes for all possible 1 hour duration. For example, the first 1 hour volume is from 2 to 3 p.m. and that's found by adding the flows from 2 to 3. So 739 plus 764 plus 809 plus 825. That will give us 3136 vehicle per hour. The same procedure is done for the rest values for both directions. So we found that the peak hour volume for the direction going towards Directorate of Traffic is 3233 vehicle per hour, and for the other direction it is 3054 vehicle per hour. Both directions have the same peak hour, which is from 2:30 to 3:30. After finding the peak hour volume, we calculated the peak hour factor, which is the hourly volume divided by the maximum flow in the peak hour multiplied by 4. So for the direction going toward the traffic directorate, we found that the peak hour factor is 0.98, and for the other direction it's found to be 0.981. The peak hour factor ranges from 0.25 to 1, and the values we have got are within the range. After that, we found the percentage of heavy vehicles and passenger cars in each direction as shown in the table here. Here is a sample of calculations for calculating the percentage of passenger cars going to our Directorate of Traffic. And it is the summation of passenger cars in the peak hour divided by the total volume of peak hour multiplied by 100. And it is found to be 88.9%. The same procedure is done to find the other values. Level of service is defined as the quality measure describing operational conditions within a traffic stream, generally in terms of such service measures as speed, travel time, freedom to maneuver, traffic interruptions, comfort, and convenience. At first, we will find the level of service for traffic directorate direction. From the previous slides, we got the peak hour volume and it was 3233 vehicle per hour, and the free flow speed is 87.38 km per hour or 54.3 miles per hour. The peak hour factor is 0.98 and the number of lanes are 3 in each direction. The percentage of heavy vehicles is 11.1% and ET value is 1.5 assuming level terrain for the highway. PR and ER values are 0 because we are assuming that there are no recreational vehicles traveling in the highway. After that, we calculated the adjustment factor for heavy vehicles by this equation shown here, and we found it to be 0.947. And for FP value, the adjustment factor for familiarity of users of the highway, we choose it as 1 because the highway is constructed long time ago and most of the drivers are familiar with that highway. Then we calculated the demand flow rate by this formula shown here, and we found it to be 1161 passenger car per hour per lane. After that, we used the speed flow curve for multi-lane highways. We used 55 miles per hour free flow speed curve, and we draw a line from the flow value, which is 1161, till it intersects with the 55 miles per hour curve. As shown in the figure, the level of service is C, and because our flow is less than 1400, then the average speed S will be 55 miles per hour, same as the free flow speed. And to have another check, we calculated density as flow divided by speed, and we found it to be 21.1 passenger car per mile per lane, which is in the range of level of service C density, so it's correct that this direction has level of service C. The same procedure is done for the other direction. So as we see, the peak hour volume is 3054 vehicle per hour and the free flow speed is 87.38 km per hour or 54.3 miles per hour, and the peak hour factor is 0.981, and the number of lanes for each direction is 3. The percentage of heavy vehicles here is 9.5%, and the ET value is 1.5 for level terrain. The PR and ER values are 0 because we are assuming there are no recreational vehicles as discussed before. We calculated the adjustment factor for heavy vehicles and it was found to be 0.955, and if p-value it is 1. Then we calculated the flow demand rate and we found it to be 1087 passenger car per hour per lane. Here also we used the speed flow curve for multi-lane highways. We used the 55 miles per hour free flow speed curve, and we draw a line from the flow value, which is 1087, till it intersects with the 55 miles per hour curve. As shown in the figure, the level of service here is C. Because our flow is less than 1400, then the average speed will be 55 miles per hour, same as the free flow speed. And to have another check, here we have calculated the density, which is flow upon speed, and we have got 19.76 passenger car per mile per lane, which is also in the range of the density for level of service C. So that's another check to make sure that this direction has level of service C.